this is my Mobius transformation. The question is find the Mobius transformation, so I am using implicit form. So this is my implicit form, correct? So let us put the values. So you are having w minus w1. What is the value of w1? That is I, correct? And 1 minus, this is w3 by w2. So denominator में w2 है, so it is going to be 0. And here I'll be having what? W minus w3. W3 is 1. And here 1 minus, again this is denominator w2, so this is 0. So this is gone. Multiply by what? Z minus, what is z1? That is 1. What is z2 minus z3? Z2 minus z3, that is 0 minus minus 1. And that is divided by, again, z minus z3. That is z3 is minus 1. And z2 minus z1, that is 0 or minus 1. So let us solve this thing. Here you are having 1 1, so this is w minus I upon w minus 1, that is equal to what? This is z minus 1 upon, this is minus, multiply here, so it will be, this is z plus 1 na? So it will be what? Minus z minus 1, correct? Yes. So now what you should do, you should cross multiply and find the value of w. वही चाहिए था अपने को. Let us quickly do that. If you cross multiply this with, और you can do one thing, ये जो माइनस है इसको बाहर ही रखता हूँ मैं, माइनस इसको दे देता हूँ in the next step, that is this will be 1 minus z upon z plus 1. Now this is good. I am giving this minus to this guy. So let us do cross multiply. Observe that this is w minus I. So once you multiply with w into z, so it will be wz plus w where minus iz minus I. On the right hand side it will be w minus zw and minus 1 plus z. Okay, let us see if something is getting cancelled. W is both the side, it is getting cancelled. Wz plus minus है तो कुछ नहीं हो सकता, and yeah, other thing will be as it is. So let us take w aside, wz, and here zw, so it will come here, so it will be 2 times zw. 2zw, that is equal to, put this that side, that is z टर्म कौन है, यहाँ पे भी z है, so 1 plus iz, that is 1 plus I times z, and what is this, minus I will go there, plus I, so I minus 1 plus I minus 1, and what is now w? W will be 1 plus iz plus I minus 1 divided by 2z. So this is what I am having. W means what? T of z. I am getting T of z equal to 1 plus iz plus I minus 1 upon 2z. Let us quickly check कि पीछे भी वही आया था क्या, 1 plus I minus 1. Yeah, see, 1 plus I minus 1. Perfect. From the both the method I am getting the same value. So actually this is quite easy to do instead of doing that, but the choice is yours. Whatever you feel good, you may try that. This is all about your Mobius transformation, correct? If you want to solve some more problem, then I can give that as a homework. You just in the, I think in the practical sheet there are so many problems, so I may skip that for now. Okay. Yeah, that is okay. Okay, so let us go to the next part, that is sequence and series in Z. Actually the main motto was to do Taylor series, but before going to Taylor series you should aware about sequence and series in Z. So let us quickly do that, then we'll see. Convergence of a sequence. सीक्वेंस, यहाँ पे भी सेम सीक्वेंस का डेफिनेशन क्या रहेगा, इट इज Zn to C from natural number to C, correct? How do you say sequence is convergent? Same thing, same example. Say Zn converges to Z, so how will you define that? That is for all epsilon positive, there exists what, n naught belongs to natural number such that mod of Zn minus Z, that is less than epsilon for all n greater than equal to n naught, whenever n is greater than equal to n naught. So same thing, जो उधर definition था इधर भी वही है, everything is same. And how do you write? You write it as limit n tending to infinity Zn equal to Z. This is how you write, correct? And one more thing, if you remember, that is, if there is no limit then it is given, that is okay. One more, I may write it as theorem. Zn equal to say xn plus Iyn, that is coordinate sequence, and say z equal to x plus Iy. Okay, so limit n tending to infinity Zn, that is equal to Z if and only if what, each of the coordinate function converges to that. That means limit n tending to infinity xn, that must go to x, and limit n tending to infinity yn, that must converge to y. So the proof is simple by using epsilon delta. And if you remember from your SYBSc refer multivariable calculus 1, that is I have proved, if I even lecture recording is also available, you just go through the proof. The proof is quite simple. You just have to play with the epsilon delta, that's it, correct? Here the thing is that here you are having Z all the time, there you are having xn and yn. In the SYBC the question is like this: if you are having sequence of x and yn, this converts to xy if and only if xn converts to x and yn converts to y. So I'm not going to the proof, this is just hint. You try this and I'm sure you will able to do that. Okay, so let us see some example. That is, say Zn equal to 1 upon n cube plus I hai. So what will be my limit? You just have to take limit n tending to infinity Zn as it is, जो पहले करते थे. So you already know 1 upon n cube, that goes to 0, so answer will be I. So this is what Zn converges to I. And if you want to prove, you can prove that. And there may be a question that you'll be given some epsilon ka value and you'll be asked to find the delta, or asked to find the n naught, and that is also easy. You just have to follow the definition, correct? Okay, so yeah, this was let me just talk about one more example. Say Zn equal to minus 2 plus I times minus 1 raised to n upon n square. Suppose this is my question, and now you would like to know what is the limit of this, correct? So what will you say? What do you know about limit? Limit n tending to infinity of Zn, that is equal to what? This is minus 2, this is minus 1 raised to n upon n square, but this is upon n square, so this is gone, na? So answer is minus 2, correct? Yeah, okay. Okay, just one exercise for you. You got to know that Zn goes to minus 2. Can you see if you are using polar coordinate, then what happens? If using polar coordinate, that means you have to first calculate Rn. So Rn will be mod of Zn. And what is theta n? Theta n will be argument. See, I'm writing capital A, so it is principal argument. Zn n equal to say 1, 2, 3. Think about it whether Rn and theta n converge or not. Exercise to think. We'll discuss this in the next lecture. check whether if your sequence is convergent, whether your Rn and theta n also converge or not. Okay, and you'll see a strange thing, that is this Rn, that is mod, that converge was theta and it does not converge. You'll see why this is happening. We'll talk about later on, but I am just asking you to do this. Okay, the next part is what is convergence of series. Same thing. How do you define a series? That is summation of Zn n equal to 1 to infinity. How do you define Z1 plus Z2 plus everything, say plus Zn plus so on. Correct? What do you define? You define a partial sum, correct? You define Sn. What is Sn? Z1 plus Z2 up to Zn. If you are having problem with convergence of series sequence, you can refer to the calculus 1 from FYBSc, and calculus 2 also it is going on, so you may see that your basic will be good then. And how we will say this series is convergent? Correct, the series of complex number convergent to S if Sn converges to S, correct? Then you say that summation of Zn that is equal to S. And this is how you define convergence of a series. Okay, and same thing series में भी वही आएगा तुम्हारा question, whether if you are having, say, suppose Zn equal to say xn plus iyn, correct, and say S equal to x plus iy, and you are having summation of Zn that goes to S and equal to 1 to infinity. So it is if and only if what, if your real part, that is summation of xn, that must go to x, and summation of yn that must go to y. Say n equal to 1 to infinity, n equal to 1 to infinity. Same thing, same as before. You just have to talk about their partial sum. Get the partial sum of this zn, so usko break karo real and imaginary part में. The real part will be the partial sum of this and imaginary part will be the partial sum of this. This is exercise. And what is the next thing? Nth term test, if you remember, that is if a series of complex number, everything I am doing it is of FYBSc, complex number. The word is real number की जगह पे complex number है, that's it. Number converges, then the nth term converges to 0 as n goes to infinity, correct? That is as simple as that. So if you are having a series summation of Zn that is convergent, implies your Zn must go to 0. This is your nth term test. Nth term. This is necessary condition. This is not a sufficient, correct? That means if you are having nth term goes to 0, I cannot say that summation of Zn that converge. Okay, so you think about this. So what is next? Next is absolute convergence. What do you mean by absolute convergence? Correct. Summation of Zn is said to be absolutely convergent if summation of mod Zn is convergent. Correct. Same thing. And after this, there is one more theorem that absolute convergence implies convergence of series. Next, absolute convergence of a series implies convergence of series. Correct. And why this is so? Because it is just mod लेना पड़ता है. That's it. You say mod xn. What is mod xn? It will be square root of xn square. Mod xn is less than equal to square root of mod zn. Correct. And same goes for yn. So each of your sequence converges. And that is I say. Just follow that. Same as your FYBS. Yeah. Okay. Next thing is what? Yeah. What is that? Yeah. Geometric series. That is what? 1 plus z square. Correct? That converts to what? It converts to 1 upon 1 minus z if whenever mod z is less than 1. Correct? This is what your geometric series is. If you quickly try to prove, then look at your Sn. What is Sn? 1 plus z square to z raised to n. Let us talk about z into Sn. So just multiply z both the sides. So it will be z plus z square plus it will be z raised to n plus z raised to n plus 1. Subtract those two things. Subtract this in this. So here I will be having what? 1 minus z into Sn. And on the here everything will get cancelled. I'll be just remaining with 1 minus z raised to n plus 1. So what is your Sn? Sn is 1 minus z raised to n plus 1 upon 1 minus z. So when this Sn converge, limit of n tending to infinity Sn, this will be 1 upon 1 minus z only if mod z is less than 1. Correct? If you remember your standard sequence, that is if mod z is less than 1, then z raised to n plus 1 that goes to 0. Yes. Okay, so finally we are in a state to define the convergence of a even if I talk about there are two more um, important things. I should just write it for you. That is summation r raised to n sine n theta. This converges to something in summation r raised to n cos n theta. Okay, where your r is between 0 to 1. So where does it converge? जब r raised to n sin n theta है तो it converges to r sin theta upon 1 minus 2r cos theta plus r square. And here if you are having r raised to n cos n theta, so it converges to r cos theta minus r square upon 1 minus 2r cos theta plus r square. Correct. And if you want to prove this convergence, then you can use prove that by using your geometric progression. See, sine n theta cos n theta, you know one thing, e raised to I theta, that is e raised to I n theta, that is equal to cos n theta plus I sin n theta. So you can relate it with your power series, with your geometric progression. Okay, yeah. Now we are in a state to define what is Taylor series. What is Taylor series? सेम ये भी वैसे ही रहेगा जैसे पहले था तुम्हारा उधर. suppose suppose that a function f is analytic throughout a disk say mod of z minus z naught that is less than r naught centered at z naught radius r naught, centered at z naught and with radius r naught, radius r naught. Then f of z has the power series representation that is defined as f of z that is equal to summation n equal to 0 to infinity. This is a series en z minus z naught raised to n, where what is the condition, that is mod of z minus z naught that is less than r naught. This is what your condition, where what is your en, where an is equal to f nth derivative at z naught upon n factorial. Correct, this is your Taylor series. Same उधर भी यही था, if you remember. Correct, that is the, you can say this series converges to f of z in that open disk, in this disk this series converges to f of z. Correct. If you want to write the expand form of this, then it will be just like f of z equal to f of z naught plus f dash of z naught upon 1 factorial into z minus z naught plus f second derivative of z naught upon 2 factorial into z minus z naught the whole square plus f third derivative f third derivative of z naught, sorry, of z naught upon 3 factorial into z minus z naught raised to whole cube and so on, where mod z minus z naught that is less than r naught. This is the condition you are having. Correct. This is your Taylor series. So if you are given any function, you can quickly do, and the what is required to you, required thing is Mclaren series भी होता है. What is Mclaren series? If you put z naught is 0, put z naught is 0, then that series is called Mclaren series. And what is that? F of z equal to summation n equal to 0 to infinity f nth derivative at 0 upon n factorial z raised to n. That's it. This is your Mclaren series. So everything is same, जो भी वहाँ पे था वही यहाँ पे भी है. Correct. No. Do I have some time so I can discuss the proof? Okay. Actually, I have code so many things. I think I should not to move ahead to the proof. Let us see the example first. Some examples, then we'll see the proof in the next lecture. Okay. Suppose you are having a function e raised to x. F of z equal to e raised to x, e raised to z, say. Okay, and the question is, ask the Taylor series around z equal to 0. That is the Maclaurin series. So what do you observe? What is f of 0? That is e raised to 0, that is 1. What is f dash of z? That is again e raised to z, and f dash of 0, that is again 1. And do you observe that f nth derivative at 0 is 1, so everybody is 1. So if you put it in the series, so it will be e raised to z equal to summation n equal to 0 to infinity f nth derivative at 0 upon n factorial into z minus 0 the whole raised to n. This is the formula. Correct. So e raised to z equal to what? Summation n equal to 0 to infinity, this will be just z raised to n upon n factorial. Correct. So this is your expansion of e raised to z. Correct. Similarly, अगर z को x पे fix किया तो you will be having that. Here what is the condition? Mod z is less than infinity. Anything, it is true for any values of z. There is no issue. Correct. Okay. Now there may be some question that uh, can you find the power series of z square e raised to 3z? Correct. So you don't have to separately do that. You know the expansion of e raised to z. What is expansion of e raised to z? It is summation n equal to 0 to infinity z raised to n upon n factorial, correct? So you want to find e raised to 3z. So it will be e raised to 3z. That will be at the place of z you are having 3z. So it will be summation n equal to 0 to infinity. It is 3z raised to n upon n factorial. This is done. Now you want z square. You just multiply by z square. Z square e raised to 3z, that is equal to summation n equal to 0 to infinity. It will be 3 raised to n z raised to n plus 2 upon n factorial. That's it. As simple as that. So by using this you can get that. Correct? And one more thing, suppose you want to find the expansion of sine z, then sine z, you know that sine z can be written as what? E raised to iz minus e raised to minus iz upon 2i. So by using e raised to iz and e raised to I, you'll see that only odd terms will survive. That is, even directly also you can do. Then the answer will be only the odd terms. That is summation n equal to 0 to infinity minus 1 raised to n z raised to 2n plus 1 upon 2n plus 1 factorial. Correct? Same goes for cos z. You are having the formula for cos z also, correct? What is the formula? That is e raised to iz plus e raised to minus iz upon 2. So here also it will be just all even terms. Cos z will be summation n equal to 0 to infinity minus 1 raised to n z raised to 2n upon 2n factorial. Correct? Same as your previous one जो पहले था. Correct? Okay. Now you know about sine hyperbolic and cos hyperbolic. Correct? What is sine hyperbolic of z? Do you remember sine hyperbolic of z? That is equal to minus I times sine iz. See, sine hyperbolic, it can be written as minus I times sine iz, and I know this expansion of sine z. So by solving that, I can get the expansion for sine hyperbolic of z, and even cos hyperbolic of z. I have already talked about sine hyperbolic and cos hyperbolic, correct? So it will be what? It is just same as cos hyperbolic. So you remember these two things. By using these two things, if you put it here in your function, by solving that, you will get that sine is hyperbolic. It will be just this minus 1 raised to n will get vanished. It will be all positive terms. And where for cos z, it will be all positive terms. That is minus 1 raised to n will vanish. You check that. That is your sine hyperbolic of z. It will be just summation n equal to 0 to infinity. It will be just z raised to 2n plus 1 upon 2n plus 1 factorial. That's it. Same for cos hyperbolic of z. It will be just n equal to 0 to infinity. It will be all even terms. Z raised to 2n upon 2n factorial. That's it. Correct? Here you are having minus 1 raised to n. Here also you are having, but here you don't have any minus 1 raised to n. It is as it is. ठीक है? And one more thing, that is, if your function is this 1 upon 1 minus z. So what is the Taylor expansion? You already know that this is same as your geometric progression, correct? 1 plus z square mod z less than 1 बोल दो. So this is already you are having. So what is the Taylor expansion? This is my Taylor expansion. You can do one thing. In the question, suppose somebody is asking about, can you give me the Taylor expansion of 1 minus z the whole square? Correct? So this is the question. Find Taylor expansion of this. Taylor expansion of this. So what will you do? You observe that I know something about 1 upon 1 minus z. That is, I know that 1 upon 1 minus z equal to what? 1 plus z square plus z cube. Sorry. 1 plus z square plus z cube, like that, correct? And do you know that this is 1 upon 1 minus z the whole square? So if I differentiate this 1 upon x, what is the derivative of 1 upon x? What is the derivative of 1 upon x? that is minus 1 upon x square. So I don't care about minus. Look at this, I'll get 1 upon x square. So can I differentiate the whole equation? If I differentiate here, I'll be having what? Minus 1 upon x square, that is 1 minus z the whole square into derivative of 1 minus z, that is again minus 1. And here derivative will be 1 is the derivative 0, z is 1 plus 2z plus 3z square plus so on, correct? So minus minus gone. Here I'm having 1 upon 1 minus z the whole square. I'm having 1 plus 2z plus 3z square and so on. That is, I can write it as n into z raised to n minus 1, correct? Summation n equal to 1 to infinity से. अगर n equal to 0 से start करना है, you can start with n plus 1 और यहाँ पे n, that is okay. So this is my power series. So always try to see whether what you want to find, whether you want to find this, then you want to find this, then you have some relation. Suppose 1 upon 1 plus z चाहिए, तो you just have to put at the place of z, you have to put minus 1 everywhere. That's it. Try to observe this thing, correct? Okay. Suppose one more question, if you want to find this, say find find Taylor series of this z into cos hyperbolic of z square. So you already know cos hyperbolic of z, correct? What is cos hyperbolic of z? It is all even terms. Summation z raised to 2n upon 2n factorial. 2n factorial, correct? N equal to 1 to infinity. Sorry, n equal to 0. So this is cos hyperbolic. Now I want cos hyperbolic of z square. So this will be cos hyperbolic of z square will be what? It will be summation n equal to 0 to infinity. It will be z raised to 2n. It will be 4n. Na? It will be 4n upon 2n factorial. And what else I want? I just need to multiply by z. So z into cos hyperbolic of z square, that is equal to what? Summation n equal to 0 to infinity z raised to 4n plus 1 upon 2n factorial. This, see how easy it is. You don't have to do everything. You can just relate with them. Correct? Yeah, good. See, in all these cases जो भी मैंने किया है, ये सब में मतलब sin cos का, because mod z is less than infinity था. You take any mod z, it is true for sin, cos, tan. Okay? But in some cases, the domain will be given to you. Correct? So accordingly, you have to do. Suppose z equal to 1 के लिए e raised to z को बोला, say find the Taylor series f of z equal to say e raised to z around z not equal to 1. So that means what you want to now form? You want to form this is summation yeah, f nth derivative at 1 upon n factorial into z minus 1 raised to n. This is what you want to find now. So let us find the derivative. It will be always e only. F nth derivative at 1, it will be always e. So you just put it in this and you will be having f of z, that is what e raised to z equal to it is e upon n factorial multiply by z minus 1 raised to n. That's it. This is what you are having. Where now you are having mod z minus 1, that will be less than infinity. Correct? So accordingly we can do, there are so many things. Okay? So in the next lecture I'll prove the proof of Taylor series. Okay? So I'll stop now. Thank you so much everyone.